This one I think is a fun problem, but you know, I think each of us have different ideas of fun. So here we're wanting to find the number of oxygen atoms in 5 moles of oxygen molecules. Okay, so here we've got a certain amount of particles that are made up of smaller particles. So let's think about this. Since we're dealing with molecules, there's a covalent bond here, so I can't just go straight to atoms if I've got moles of the molecules. So instead, I need to think about a couple things. So oxygen is a diatomic molecule, meaning it's 2 oxygen atoms covalently bonded together. Okay, remember back in the day, we took 2 oxygen atoms and formed a double covalent bond, but remember you can't write it like that. It looks like a little face. Instead, you've got a double bond here in the middle. All right. This oxygen molecule is made up of 2 oxygen atoms. There's oxygen atom number 1 and oxygen atom, number 2, all in one molecule. So if I've got 5 moles of these molecules, I should have twice the number of atoms, but we can use dimensional analysis to get that figured out. Okay. So I've got 5 moles of oxygen molecule, so O2. Okay. I can go ahead and get that to molecules. Okay. So I can get out of moles and into molecules by saying that 1 mole of O2 molecules is Avogadro's number, so 6.02 times 10 to the 23rd molecules of O2. Okay. My moles cancel. But I don't need molecules, I'm looking for atoms. So I can use another conversion factor and say that for 1 molecule of O2, I've got 2 atoms of oxygen. So since I've got molecules in my numerator, I want it in my denominator now so that the units cancel. So I'm going to say every 1 molecule of O2 has 2 atoms of oxygen in it. Okay? So the molecules cancel and we're left with atoms of oxygen, which is what we asked for. So, alright, so let's figure out how many atoms that is. So we will do 5 times Avogadro's number. And realize how I put that in parentheses. I'm closing my parentheses. And really I can just multiply all the way across. So times 2. And I get 6.02 times 10 to the 24th atoms. Okay. I want to point out how, see how I have 6.02, that almost looks like a mole, but it's another order of magnitude higher. It went from 23 to 24 for the exponent, so I multiplied by 10 again. Well, I took 5 and 2 and multiplied them, so our answer does make a lot of sense. Okay, we basically just took Avogadro's number and multiplied by 10.